Hello friends. Welcome to Defense Matrix. On this channel you will get fully information about defense and technology. Let's view the video. The insane engine ring of X-15, the Cold War race for the skies, why the X-15 was built. Imagine a time when the world teetered on the edge of global destruction, the Cold War. Two superpowers, the United States and the Soviet Union, were locked in a silent, relentless race not just for military dominance, but for control of the skies and even outer space. Missiles, satellites, and spy planes weren't enough anymore. The question now was, who would touch the edge of space first? Amidst this high-stakes geopolitical chess game, the US unveiled a secret weapon, the X-15. But this wasn't just an aircraft. This was a rocket-powered machine, capable of flying higher and faster than anything built before it. It was part jet, part spaceship, and all muscle. The X-15 was never meant to be a weapon, it was a flying laboratory, designed to collect data no one else could reach. The Air Force and NASA joined forces to break barriers no human had ever crossed: extreme altitudes, hypersonic speeds, and near-space conditions. Why was this necessary? Because traditional planes and jets were hitting their physical limits. To reach the next level orbit, moon landings, hypersonic weapons, the world needed new data, new technology, and new heroes. And so, the X-15 was born out of urgency, fear, and the unquenchable thirst for dominance. This aircraft didn't just push boundaries, it obliterated them. In a world where survival depended on who had the highest ground, the X-15 went straight up, unmatched engineering, breaking down the X-15's supersonic design. At first glance, the X-15 looks like something straight out of a sci-fi movie, sleek, black, and deadly fast. But beneath that menacing exterior lies some of the most advanced engineering of the 20th century. Built by North American Aviation, the X-15 wasn't designed to glide, it was built to slice through the atmosphere at Mach 6.7, nearly 7 times the speed of sound. That's over 4,500 miles per hour. To put that in perspective, at top speed, the X-15 could fly from Los Angeles to New York in under 30 minutes. Its skin was made of Inconel X, a nickel-chrome alloy capable of withstanding temperatures above 1,200 degrees Fahrenheit, generated by the intense friction of hypersonic flight. Conventional metals would melt. This thing was forged to survive hellfire. Then there's the rocket engine, the reaction motors XLR-99. It was the first man-rated rocket engine that could be throttled, shut off, and restarted in flight, an absolute engineering breakthrough. With 57,000 pounds of thrust, it could launch the X-15 nearly vertically, simulating space launches decades before the space shuttle. But what's even crazier? It had no onboard navigation like we know today. Everything relied on manual pilot control, based on test data, visual indicators, and sheer gut instinct. The engineers had to rethink everything, from thermal shielding to control surfaces that worked at the edge of space where air becomes almost non-existent. Every rivet, every bolt, every design feature had a purpose: to survive the impossible. This was not just a plane, it was a mechanical marvel, built when computers barely existed. The X-15 was handcrafted hypersonic madness, and it worked. Pilots or astronauts? Inside the cockpit of the X-15, climb inside the X-15, and you'll instantly realize this wasn't built for comfort. The cockpit was cramped, claustrophobic, and terrifying. It wasn't a seat, it was a survival capsule. Pilots who flew this beast weren't just military men, they were test pilots, scientists, and daredevils, all rolled into one. These were the men who strapped themselves to a rocket, lit the fuse, and blasted into near space, with no guarantee of return. Neil Armstrong, yes, the Neil Armstrong, the first man on the moon, flew the X-15. So did legends like Joe Walker and Scott Crossfield. These weren't your everyday pilots. They had to train for zero-G, endure violent G-forces, and learn how to fly in conditions that were essentially spaceflight, where air is too thin for traditional control surfaces and gravity feels like an afterthought. Inside the cockpit, every move had to be perfect. One mistake at Mach 5, and you're not just crashing, you're disintegrating. The pilots had to memorize dozens of emergency procedures, react within seconds, and maintain perfect composure while traveling faster than a bullet. The control stick wasn't just for pitch and yaw. At extreme altitudes, reaction thrusters would take over, letting the pilot orient the plane in space using rocket bursts, the same technology later used on spacecraft. Were they pilots? Were they astronauts? The truth is, they were both. Decades before space tourism, before reusable rockets, before SpaceX, these men danced on the edge of Earth's atmosphere and came back to tell the tale. Inside the X-15 cockpit, every flight was a gamble. But without them, we wouldn't have the Apollo program, the space shuttle, or the dream of hypersonic flight. Large Blue Diamond 4. Extreme flight, how the X-15 redefined the edge of space. The X-15 didn't just fly, it launched. Strapped beneath the wing of a B-52 bomber. It would be carried high above Earth, then released like a missile. The moment its XLR-99 rocket engine ignited, the world below vanished in a trail of fire and thunder. This wasn't a plane taking off, it was a controlled explosion, sending the aircraft hurtling toward the edge of the unknown. At full burn, it reached speeds of Mach 6.7, climbing over 350,000 feet, that's over 100 kilometers above sea level, officially crossing the Kármán line, where space begins. Pilots didn't see clouds or landscapes. They saw curvature. They saw stars during daylight. They saw Earth from space long before astronauts regularly did. The temperature outside dropped to hundreds of degrees below zero, yet the friction from hypersonic speed raised parts of the aircraft to glowing red heat, and there was no autopilot. Every maneuver, every roll, pitch, yaw had to be done manually, with rocket thrusters, because at that altitude, air is almost non-existent. The pilots flew using reaction control systems, similar to what we use on spacecraft today, but it wasn't just about speed or altitude. The X-15 was flying into uncharted airspace. It discovered new boundaries of human physiology, engineering endurance, and what materials could survive the heat of hypersonic flight. The data gathered on each mission helped NASA develop re-entry techniques, heat shields, and flight control systems used in the Apollo missions and the Space Shuttle. Each flight was a brush with disaster, but also a leap into the future. And though the X-15 stopped flying in 1968, its legacy is alive in every satellite, every rocket, and every reusable spacecraft. The X-15 didn't just reach the edge of space, it redefined where flight ends and space begins. The legacy, how the X-15 paved the way for hypersonic weapons spacecraft. The X-15 wasn't just a test flight program, it was a glimpse into the future of defense and aerospace. Every discovery made aboard this rocket plane laid the foundation for the space shuttle, intercontinental ballistic missiles, and today's hypersonic weapons that can travel at Mach 10. Technologies like heat-resistant alloys, reaction control systems, and data telemetry, all pioneered on the X-15, are now core components of modern defense systems. Even today, militaries around the world are racing to develop hypersonic glide vehicles and spaceplanes, a race the X-15 started over 60 years ago. Without the X-15, we might never have had Neil Armstrong's moon landing, SpaceX rockets, or the emerging threat of hypersonic missile warfare. Its mission may be over, but its impact is still accelerating, shaping the future of warfare, defense, and the final frontier. Thanks for watching. Subscribe our channel Defense Matrix for more interesting and knowledgeful videos.